I didn't hear you. Go.
Hi.
All right, Thaddeus. That was Thaddeus. So if you watch this video, that's Thaddeus. You got to know Thaddeus to understand that. Okay. All right. Number 1. 16 to the x is equal to 4. So I'm going to use, since Thaddeus was talking, I'm going to use him as an example. He did almost every one of those last problems without any work at all. So we're going to put him to the test. So Thaddeus, 16 to what power is equal to 4? Dun, dun, dun! Is it 16 to the first power?
-2.
-2.
Final answer.
Final answer. Okay, so could we call your method of madness here trial and error? Okay, so his method of madness is, let's just try a whole bunch of numbers until we get the right answer, which is nothing wrong with that, okay? But it could take you some time if you're just guessing. And could we say that trial and error is somewhat an educated guess? Okay, so does everybody know how to take their scientific calculator and do 16 power key -2? So just in case you want to be a Thaddeus and you just want to guess.
I got it right.
Okay, he got it right because he's going to argue with you every single time. So your power key is an upside down V. Some people call that the caret key. So he guessed, okay? He started putting in numbers. The positive powers were not making sense. Why was 16 to the +2, 16 to the +3? Why was that not making sense? Yeah, the answer's got to be small, like 4. So that probably means the exponent is going to be a negative number or maybe even a fraction. Okay? So if you do 16 to the -2, I don't get 4. 16 power key -2. 16 power key -2. Did you get 4? No. Okay. Is anybody else going to guess what it is? All right. So Dax is guessing it's 16 to the 1/2. So let's check that in our calculator. 16. Upside down V is your power key. Some of y'all are not even trying it. Y'all are just sitting there. That's okay. 16 to the 1/2 power is 4. Dax got it right. It is 1/2. Okay? So, there is this method called trial and error. You can do it that way, or you can get both sides to have the same base and set the exponents equal. That's called the algebraic method. Okay, I would suggest that you do that because sometimes you're going to be just trying a whole bunch of numbers and you might not ever find the number. Okay, so both sides can be written as the same base. What base would that be? 16. Can I write 4 with a base of 16? What would be easier, to write 4 with a base of 16 or write base 16, rewrite it as 4 to some power? Do y'all see it would be easier to change to 16? Okay. 4 to what power is 16? 4 to the second power. So I want everybody to understand what we've done right here. All we've done is we've changed the way 16 looks. Okay. It was 16, and now we've changed it to 4 squared. Still the same number. 4 squared is 16, so we haven't changed the problem. Still the same number. But my 4 squared is raised to the raised to the x power, excuse me. All right, I'm going to show you how to algebraically work this problem and not just guess with your calculator. So this is how I want you to work it unless you just have to guess. Okay? Now, on your foldable, on your exponent foldable, we learned what to do when we have a power raised to another power. Power to a power. What do we do with those powers? We multiply them. What's 2 times x? 2x. So the left-hand side is 4 to the 2x, and the right-hand side is 4. What's the power on the 4 on the right-hand side? A 1. Does everybody agree with that? Now, do you have both sides in the same base? Yes, once both sides are in the same base, what can you set equal? Once both sides are in the same base, what can you set equal? It starts with an E. Exponents. So if the bases are both 4s, then 2x would have to be equal to 1. If the bases are equal, then the exponents are equal. If the bases are equal, then the exponents are equal. And then you solve for x. So if you have 2 times x, how do you solve for x? Divide both sides by 2. The 2's cancel, and x is then equal to 1/2. All right. It's okay to guess, but it's better to have a direct way to solve the problem. Okay? If you're not sure how to get to Austin High School, then you can do trial and error. But it would be a much better way if you knew to go down 6th Avenue, to go down 31, go over the River Bridge, go down 6th Avenue, turn right on Gordon Street, go all the way over the railroad tracks, go a couple more blocks, take a left, drive a couple miles, and turn right, and you're at Austin High School. Or you can just drive around for a while, okay? And if you're guessing, you're just driving around. So it's better to have a direct way. So that's what we're doing. All right, number 2. 27 to the x power is equal to 3. So let's do this the direct way. Let's not just guess unless we have to. All right, I can rewrite 27. Okay, how can I rewrite 27 with a smaller base? That's why I wanted y'all to have some numbers memorized. 27 is the same as 3 to the 3rd power. So I'm going to rewrite 27 as 3 to the 3rd. It's still raised to the x power. On the right-hand side, I have 3 to the understood 1. I just changed 27 into 3 to the 3rd. Then I'm going to do power times my power. So that's really 3 to the 3x is equal to 3 to the 1. 3 to the 3x. 3 times x is 3x. 3 to the 3x is equal to 1. Now my bases are equal, so I set my exponents equal. So my equation is going to be what? 3x is equal to 1, and I solve 3x is equal to 1 by dividing both sides by 3. My final answer is going to be x is equal to 1/3. You're finding the value of x. Then you can take your handy-dandy scientific calculator and you can check that. Okay? Somebody tell me how you would check 27 to the 1/3. What would be the exact keystrokes that you would put in your calculator? 2, 7, upside down, V. And how do you put in 1/3? You could, or what's the fraction key? 1, A, B, C, 3. So 27, upside down V, which is our power key, 1/3. 27 to the 1/3, hit enter, is 3. Oh, that's my school phone. Oop, let's pause this. I divide both sides by 5. And your final answer is 2/5. Now, do you see how much harder it's going to get to do these by trial and error? You see how much harder that is? Just agree with me. Just make me feel really good. You agree with me, right? It's going to get harder to get 2/5. Okay? So there are situations where you are going to have to show some work. Okay? Number 5. Anybody still copying number 4? All right, number 5. Start to look at it. What base can we get both sides to be in? All right, I hear a 2. Over here on my right, I hear 2. The left-hand side's already in base 2, so you don't have to change it. But the right-hand side, y'all agree that 8 can be rewritten as 2 to some power? Yes. All right, so the left-hand side doesn't have to change here. All right, let me show you what's going to happen here. 8 is going to change into 2 to the 3rd power. And then you're going to have to multiply 3 times 2x and minus 4, because you've got power to power going on the right-hand side. So the left-hand side is going to stay 2 to the 5x. The right-hand side is going to change to 2 to the 6x minus what? Nope. Minus, not 4.
12.
Minus 12. It's 3 times 2x and 3 times the minus 4. It's 3 times all of that. So you'll have to distribute your 3. Distribute just means multiply it out. Alright, now are the bases the same? Base 2 on the left, base 2 on the right. Now your exponents are going to be equal. This is the hardest one that we've done so far. So that means that 5x is going to be equal to 6x minus 12. Why is this equation the hardest one that we've seen so far? There's one answer that I'm looking for.
Because that has
Two x's, and they're both on opposite sides. That makes the equation harder to solve. That's just considered a harder equation. So how are we going to solve for x if I have a 5x on the left and a 6x on the right? Okay, we usually do move the smallest one, but why would it not be a good idea in this particular problem to move the 5x? Because if you move the 5x, the left-hand side goes to nothing. And we really, in an equation, we don't like for one side to go completely away. So in this one in particular, we're going to have to move the 6, even though it's not the smaller one. So 6x is positive. So if I move that whole term, I'm subtracting it. If the whole term is positive, you're moving it by subtracting. We're trying to get all of the x's on the same side. Anytime you have an x on both sides, you got to get them all on the same side. So 5x minus 6x is negative 1x. On the right-hand side, the 6's are going to cancel, and you're going to be left with a negative 12. We're almost finished. So if our equation says negative 1x is equal to negative 12, how do we solve for x? You can, or you could also divide both sides by a negative 1. She said multiply both sides by negative 1. That would work. Or since it's negative 1 times x, it makes a little bit more sense in my brain. If you're multiplying by negative 1, then you need to divide by negative 1. The negative 1s are going to cancel, and your final answer is going to be negative 12 divided by negative 1, which is positive 12. Final answer here, positive 12. See how these are going to get harder? It's going to be much harder to do trial and error on these. You're going to have a direct way to get there, and that's considered solving the equation algebraically. All right, y'all try number 6. You try number 6. I'm going to hit the pause button, and then as negative 5. This one's pretty hard. Okay? You have to change 32 into 2 to the 5th power. And this is where a lot of people make a mistake. Y'all listen to me. Shh. Okay? Between these two steps right here, a lot of people guess what the careless mistake is. Between these two steps right here. Between these two steps right here. Guess what people... Yep. They do 5x, and then they do plus 1 instead of plus 5. They forget to distribute that 5 out. Okay? Is there anything about 6 that you do not get? And you do not have to show every single step. If you can get the right answer consistently, and you know what you're doing, and you can shorten the work, that's up to you. Okay? I have to teach it, so when I teach it, I have to show all the steps just to make sure everybody sees what's going on. All right, last one. Everybody got 6? All right, last one for the day. We'll be done. Number 7. 243. Oh, did you memorize that number? 243. It's what? 3 to the 5th. Y'all are so smart. So 243 is really 3 to the 5th. And 9 is
3 to the 2.
3 to the 2, or 3 squared. So that means we're trying to write both sides with a base of 3. On the left, what's the next step? Power to a power, we multiply. Toki said that's going to give us negative 15x. Power to a power, we always multiply. So I'll get 3 to the negative 15x is equal to 3 to the positive 2. That gives me what equation? Negative 15x is equal to 2. Solving for x. Have we solved for x yet? Have we got x all by itself yet?
You gotta divide -15.
We got to divide by negative 15. What's a positive divided by a negative? A negative. So my final answer is going to be negative. And is there any way 15 will divide into 2? No. Is there anything that will divide into 2 that will also divide into 15 so I could reduce that fraction?
No.
No. So the final answer is negative 2 over 15. Negative 2 over 15.